the iNEMI Tech Topics series for smart manufacturing. This is part of our Future of Electronics series. We do routinely add more to this series, as well as our Sustainable Electronics series. Our next call is next week on the 23rd, which is a Sustainable Electronics webinar, and you can go to inemi.org/events to find it and other events that are going on at iNEMI. So if you're interested, I'd ask you to please register there. But today, I want to let you know that you should all be on mute, and I would ask if you have any questions to please use the chat function. We will collect those. I will watch that during the session. If there's mass confusion, I will interrupt Swami to stop him so he can clarify, but otherwise we will hold questions to the end. I will try to unmute folks if I can. It just depends on how noisy and how many questions we have on the line. But Swami has a good presentation, probably going to use up a good chunk of the time. So I do appreciate everybody's attention today. We are recording the session, and we will send out the recording and a copy of the presentation probably next week after we get done with our editing, so that everybody that registered will have that. But for now, you're here to hear from Swami, not from me. So let me turn it over to Swami. And thank you very much for being here today.
Thank you so much, Mark. Thanks everyone for being here. My goal was to talk about how Agentic AI, and particularly what is IBM doing and what IBM Storage is helping for smart manufacturing. I'm Swami Sundararaman. I'm a senior research manager and research scientist at IBM Research. And since someone actually beat me to the punch of introducing agents and Agentic AI to this broader group a couple of weeks ago, I'm not going to start on the basic foundations of what is that. But I'm going to talk about workflows, high-level capabilities of Agentic AI, how we can use for smart manufacturing, and what do we do from a storage standpoint for Agentic AI. I hope that's good with everyone. As a first, what I want to start my talk with is there are three key fundamental innovations that happen in the industry that is enabling Agentic AI or Agentic AI workflows to be possible. The first one basically is the large language models, right? So we have actually come a long way with understanding documents, understanding contents, and also the ability for these models such as GPT-4 to output information at depth that is as good as a complex human being can generate, right? So that is first part that enables the agentic workflows. The second one basically is with the integration with robotic process automation and other tooling systems where AI is now able to seamlessly connect with a lot of different systems, and in our context, different systems in the manufacturing processes, so that it can actually, excuse me, perform complex tasks and makes informed decisions working with these other tools and robotic process automation systems, right? And the third and the most important part, which is makes it more interesting for workflows, is AI can now make autonomous decisions and can create plans, evaluate the plans by themselves, and execute on the decisions and refine them to make it better, so that over time it's going to become more and more intelligent, which is, makes it more attractive for smart manufacturing use case. Okay? So for part of the characteristics of workflows, there are three key things that we can think about it. The first one is continuous learning, right? Unlike today's generative models, it's not like output once and just try to create some other output in a different way. It's about learning from what happened in the past interactions. How do you meaningfully get feedback from other agents or other systems or even from humans, and then keep improving themselves, so that way it mimics a good human behavior over time. The second thing, second thing is it has this ability to proactively reflect on its output and independently analyze its mistakes and refine them without requiring someone to explicitly tell them that, hey, you have made some mistakes, can you please fix it? Right. So that is a huge improvement over today's generative models. And finally, it can collaborate both with humans, agents, and other systems in the ecosystem that it's been deployed on, so that it can actually meaningfully exchange information to accomplish the goal that it has been designed for. And it wants to do it more efficient. So the second thing that I wanted to come talk about is why agentic AI, right? As I mentioned in the previous slide, it has three important characteristics. One is to analyze the output or its response or plans, and it automatically identifies the way it can improve itself or improve its output. It refines it, and then finally the refining process will make it iterative, that it keeps trying. It's similar to a reinforcement learning, but where it tries to learn by itself to understand what steps it took and which of those steps were meaningfully trying to get to an outcome that it wants. Right? And there are many different agentic workflow patterns. The first pattern is the reflection pattern, which is what I've been talking about earlier, where it reviews its own output before responding to a user. The second pattern is connectivity and using different tools to perform its job. The third one basically is the multi-agent collaboration. So it's not a single agent. Now you can have a system of agents, even a hierarchy of agents that can work together to accomplish a specific task. And finally, how do you create plans in order to accomplish a very complex task or part of the workflows, right? How do you create different workflows? How do you break it up into meaningful tasks, and how do you plan for them? In the interest of time, I'm just going to talk about the reflection uh, workflow design pattern, where user provides a prompt at the top in the blue box. Once it gets an input, the agent first generates an initial response and uses a model to reflect and critique on the initial response it's generating itself. And it tries to incorporate the feedback either from using a model, or it can actually, like a judge model, or it can incorporate the user feedback, and it generates the next set of improved responses. And again, it uses another large language model to validate these responses and then keeps iterating it until it provides acceptable or an optimal answer that is good enough to complete the task, given the constraints that the agent needs to work with. Okay. So again, I hope the previous talk already covered about why agentic AI is not the same as large language models or chat GPT. At a high level, agentic workflows or agentic AI can think on its own, can critique on its own work, can make decisions independently, and it can adjust its own work to improve its output or improve its answers, and it can act autonomously. ChatGPT, on the other hand, or other chatbots, does not do all of the things as part of agent workflows, right? And on the right hand side, what I'm showing is the agent tech stack. Sorry, I think I have some throat irritation. I apologize for constantly clearing my throat in the background. Right. On the right hand side, we have the agentic tech stack, where we talk about model serving on the top, which actually allows you to interact with a large language, one or more large language models. And the second part is the agentic frameworks, which allows you to create agents, orchestrate agents to different tools or different model serving systems. And then you actually have a storage solution, and storage comes in different forms, which I'll talk about a little bit later in the slides. And then it goes on to tools and libraries it needs to interact to complete this task. And finally, some sort of a platform to help with agent hosting and services that provides you a marketplace like environment. Okay. So in this talk, I'm particularly going to focus on agent frameworks and storage as what IBM is trying to do. And I'll give a little bit more deeper insights into these two topics. Um, Jumping on to what IBM is doing, IBM actually has Watson X series of software suites, And the recent addition to Watson X is called Watson X Orchestrate or Watson X Concert, where we actually want to provide a platform or a software solution that helps you to scale AI agents across your business initiatives, right? So Watson X Orchestrate does three things or provides three things which are more fundamental. At the bottom of it, it allows you to build custom agents that are purpose built for your particular domain or area of expertise. In our context, we can create custom design agents for smart manufacturing. And once we have that, we can add those agents to work with either the custom built agents or pre-built agents, which IBM has connectivity to different entities such as Slack, um GitHub, Salesforce, a bunch of other things that you have. You can also connect with it. And then you can also create an ability to orchestrate your workflows with multiple agents, but all of them can be done in a one single platform in an easy drag and drop way with with low or no code options to do those work that you want to create. Right? If I try to go down one level down, our vision basically is to provide a unified experience to help enterprises infuse AI and automation across manufacturing or business processes. Right? You have in this case, IBM deals with a large variety of customers, so we want to make sure that we help our customers with a good experience. We also want to make sure that there's productivity in terms of workers in organizations, be it manufacturing factories or be it like corporates and software development teams. We also want to help improve business performance, the KPIs that we want to do while reducing the processing errors similar to what we are trying to optimize in smart manufacturing area. And finally, we want to do all of this while ensuring compliance. At the end of the day, you also make sure that we meet sufficient standards that are uh, enforced upon us. And we want to make sure that we could do that, all of this while maintaining compliance. Right? One level down, basically, what we want to do is to provide experience with AI assistants and agents, where we provide the tools to build agents, provide a catalog of different tools you can connect to it, uh, ability to discover different agents and tools, and finally, you can also build new tools that are specific for your own domain too, right? And then we want to go from agents and tools to automation, where we want to automate processes, mining of information in processes, helping make decisions, content services, robotic or process and automation. That's something what's near and dear to most of our hearts. Operational intelligence, and finally to process and case management, right? And from Watson X or our software offering that we have foundation models or large language models that are trained on enterprise data, which adheres to strict uh, privacy, hate abuse, profanity, and other guidelines to ensure that we don't break any obvious rules and we create them in a more stringent and very inaccurate manner with also a very small footprint. Those are, excuse me, what is called as Granite series of foundation models from IBM. We also support third-party large language models beyond our own Granite series of models. We have our own prompt lab where we can try to work on the prompting and refining your prompts to improve the interaction to your agent or your large language models and your output that you receive. We have tools for governance and enforcing data compliance, sanitization, and also data preparation for your agentic workflows. In terms of a high-level architecture, so at the top you have your apologies, you have your customers, employees, and subject matter expert working with our orchestrated agents, which performs four critical tasks: supervising other agents or processes, routing of request or routing of information between the different workflows, ability to reason and improve your predictions, and finally to plan and execute on those plans through the agents, right? Of course, the bottom layer is to boost our productivity and output, and we have AI agents and tools to help you with that. And finally, we have Watson X Studio that can help you to build your own custom agents or actually use the pre-built skills that are available from n different partners that we have. Currently, we have 100 plus partners who are helping bring agents and putting these agents into the Watson X ecosystem. And we also bring in the catalog of models, as I mentioned before. And then we also have purpose-built agents for HR, sales, procurement, and you can also bring your own custom agents for your particular domain. So our goal is to eventually to unify existing and future automation capabilities to provide the agentic AI framework for Industry 4.0, where currently we are not driving too much into manufacturing processes yet, but we are starting to work on it. We are starting from IT automation for initially, but we are also moving towards manufacturing and decision-making processes in the upcoming next set of releases, right? And what we want to do basically is we want to help you to seamlessly manage your data across different types of data management solutions. We want to provide good governance on top of your AI initiatives that you have. And finally, also to help you with the process design and refining those processes to get to higher yields or higher useful throughput for your manufacturing processes, right? I want to quickly pause to see if there are any questions on the first part of the talk, where I want to move from agentic AI frameworks into storage next.
There are two questions in the chat. I can read them off to you if you'd like. So we have
that would be great, Mark. Thank you.
Yeah, so from Joshua, how similar / different is this to the reasoning models that the large LLMs use when which iterate on the answer to provide a better response? And then there's a second one as well. Actually, there's more than that.
So the agentic AI actually uses the reasoning models in order to create the plans and validate those plans. So we have this reasoning as a step, right? And the point is, it's not just a model alone. You need to create workflows, right? So in the previous one, I talked about it. You actually are going to use your reasoning model to reflect and critique your response. Similarly, you have to have a planner model to create a plan for executing a complex workflow. So the reasoning model is just one step of the agentic workflow. And we need to coordinate the execution and also the orchestration of all of the different pieces of this workflow to work well together to complete your task. For example, if in the manufacturing, if you say that, hey, I want to reduce my defects or improve the yield to 95% plus, you need to start looking at the yield level at each of the stages in your manufacturing process and say that, hey, my first level drops down to 90%. So how do I pull those one in? You're going to have an agent for that particular first step. Then your second step, third step, you have to keep doing this as part of your workflow, that you work on multiple agents, each responsible for each of those stages to work together to improve your overall yield to 95% or whatever that level that you set.
He says, thank you. There is a question from Mark De Silva. With digital transformation in manufacturing, would there be additional agentic AI workflows for monitoring and controlling digital twins of physical assets and operations and equipment, work and process flows, etc.?
Absolutely. So that's a great question. Thank you for asking. So we're also partnering with NVIDIA, where they are also bringing industry vertical specific blueprints, and they have digital. So currently, we don't have a digital twin blueprint as part of the Watson X framework, but as part of our offering, which I'm going to cover in the later slides, we actually support both IBM's Watson X and also from NVIDIA's AIQ blueprint, where we actually bring in the digital twin and other manufacturing blueprints NVIDIA provides that we will provide through our offering too. So we will be able to create these digital twins, support it, and also try to mimic and simulate some of these processes in order to improve and refine without having to spend the time on trial and error on a real system. Absolutely. Great question.
And the last one we have so far is how efficiently agentic AI algorithms resolve CUI and CTI?
I don't know what CUI and CTI are. So
Neither do I. So Amber, maybe you can unmute. Let me see if it'll let you unmute. If you're still here, Amber.
Yeah, I'm
Yeah.
here.
Yeah, can
So
you ask your
basically,
question?
yeah. CUI is classified useful information, and CTI is classified technical information.
classified. Sorry,
Whenever
what
we
is
do any
CTI? Sorry.
design or technology transfer,
Transfer. Okay.
classified useful information.
Yeah. Oh,
and
that's perfect. I
classified
think, yeah.
technical information.
Yeah. So this is great. I think, so the good part about it is I don't think we need agentic AI for the CTI and CUI. We can actually use large language models, which are extremely good at summarizing many of those things. And if you have some like a huge document, or if you have a bunch of different documents that are describing the whole technology or the processes that we are doing, we can actually work on using a large language model to improve and summarize it. How agentic AI can help is that we as humans can provide feedback and say that, hey, you did the summary, but can you change this portion of your summary in a slightly different way? If its understanding of portions of your thing are not good, you could go back and interact either in an interactive way and try to do it with large language models directly as through prompt engineering, or you can use agentic AI to give the cues so that it can work with it. This can be done in both ways, with and without agentic AI, but with the large language models that can summarize and create really good CUI and CTI documents for you.
Those are the questions we have in the chat right now. So I'd say continue on, and we'll take another pause either at the end or whenever you feel you want to try some more.
Yeah, perfect.
Thank
you, Mike. So this is great. Again, I hope I gave a quick high-level overview of what agentic AI can do and what workflows can be supported, and what does IBM do in terms of supporting some platforms to do agentic AI or multi-agent workflow orchestration. Now I want to talk about the storage challenges we have in terms of unlocking the value for AI or agentic AI, right? So as a CEO talks about, Aravind Krishna, excuse me, talks about it.
How are you, buddy? Doing okay?
Yeah, sorry. Yeah, I'm good. Thank you. So we have a fundamental problem. All of these large language models and AI are trained on public data or public information that's available on the web. But for most of our enterprise use cases, we want enterprise data to be used for these solutions. For example, if you want to do a smart manufacturing,
my lunch is missing.
Sorry, George.
Sorry. Please mute yourself if you're not speaking.
So in terms of agentic AI or smart manufacturing, you don't want the models to talk about public information. You want them to find the information that you have been using as part of your smart manufacturing, trying to bring your data as you mentioned, right? We want to make sure we provide security, we provide governance and compliance, that it's not like we just randomly expose AI to all of the information, but we want to expose it for certain users who have the privilege or have the access to those particular documents or artifacts. So we want to enforce all of those things, and we want to bring them in a safe and secure way. That is the storage challenge that we have here, right? And what we want to do, as I mentioned here, is we want to build trustworthy AI, because where we want to make sure that the AI generates trustworthy answers that are relevant and accurate to your particular domain or your particular processes or your particular problem. And we don't really care about what it has been trained on in terms of the public data. So it's useful to a certain extent, but in order for it to be used in production or in your manufacturing flows, it needs to be using your own data. So how do you make trustworthy AI is the storage challenge that we are trying to solve here at IBM, right? And the biggest problem, as you see, if people have already been using it, you have been seeing inaccurate answers. A lot of times it gives you a completely irrelevant and useless answers that are not what you're looking for. And trying to start on your AI journey is highly expensive. You have to bring in AI experts, you have to pay like hundreds of thousands of dollars, if not millions of dollars in order to bring in the equipment in terms of the GPUs, in terms of the whole infrastructure to do those things. You have to deal with security and compliance, as I mentioned earlier, and then you also have operational challenges integrating with your different set of RPAs that you have, automation processes that you have in your manufacturing solution, right? So these are fundamental big challenges we have. And the world is moving from training to inference, right? Previously, a handful of people in the industry were focused on training. They were actually building these large language models like GPT from OpenAI. We have Claude, we had Grok, we had IBM has a Granite series of models for training, but the money is not in training. Money is actually money or the value is purely in inference. And Jensen Huang said this year is the year of inference, where everybody wants to move from generative AI to agentic AI and eventually to physical AI in the future. We're still not in physical AI yet, but we are seeing glimpses of it. But we are starting to get more and more traction from generative AI to agentic AI. That's the big push we are going for this year. Eventually, we're going to see more and more push in the physical AI realm too, right? From what does that mean in the context of deploying an agentic AI inference solution, right? The fundamental thing is you have the high level AI data platform, which is like the data services that people do in terms of classifying the data, processing the data, in terms of creating metadata and searching all of those things, which is going to help you with it. The second part of it is how do you prepare this information? How do you manage this data in terms of running some information extraction, trying to generate some different embeddings for search. The third level of things is how do you bring the management and governance part of it, where you do compression, encryption, compliance, audits, rollbacks, and stuff. And finally, how do you bring in storage, serving, and protection? So these are the four high-level verticals that NVIDIA says it's required to create a good data platform for AI factories. From an IBM standpoint, we are building a content-aware storage, which helps you to address all four of these fundamental capabilities that are expected in a solution. Right? So I want to dig deep into two parts of what does it take to build a good inferencing solution. Right? A good inferencing solution requires two parts. First part is the ingestion or transforming your data into some representation that can make your data easily searchable. Why is this important? Because today you cannot, if the large language models have a limited amount of input you can take, which is called the prompt length or the context length. You cannot simply give the agent a document of 1,000 pages or 100,000 words or something. The problem there is it has a limited memory or input capability, and it will drop 90% of the things if the input is too high. So what you want to find is not only you want to say which documents or which parts of image is useful, you need to exactly go and say that not just the image, this section of image is important or this paragraph of the document is critical for you to help answer the question. So we need to convert and index that data in order to help with inference. That's the first part of data ingestion. And here it's not given that the data is complex, where you have images, you have video, you can have speech or even text with graphs or PDFs and stuff. You need to have document understanding and the capability to convert these documents into an entity that is made, it can be searchable. The second part of it is the serving thing. So you want to provide a search interface or a query interface for your agentic AI or even your users to access your storage system to search and retrieve these chunks or fragments of the files or images or videos that are relevant or helpful to answer your question. And that's the second part, which is basically the inference operation that we want to support. Right? And most of you already heard about RAG. If you have not heard about RAG, RAG stands for Retrieval Augmented Generation, where the idea is that when you want to provide an inference, or output from a large language model, rather than just making the model answer by itself, you actually find the relevant pieces of documents or information from your storage solution or your manufacturing systems that can be augmented as an input or a prompt to your model to generate a meaningful response for you. Right? And we want to operationalize it and make it secure and compliant for you. Right? And again, RAG sounds easy and simple, but it is extremely complex and a lot of challenges and limitations to it. The first part is it has a high cost because you need to move the data across different stages or different systems to copy and transform and index and stuff. There is a high cost in terms of creating multiple copies. Second thing is it's complex. You need technology to deal with images, one with speech, one with videos, one for document understanding. And even within each of these categories, there are subcategories. There is images for chips, understanding of chip data, one for automation for, let's say, vehicular data, one for uh, geospatial data. So it's a lot of different technologies have to come. Multiple models have to be used, has to be pipelined and coordinated to make that happen. The third problem, as I said, is the security exposure too, because it's not just you can expose the data blindly. You need to enforce appropriate access control and restrictions so that you don't inadvertently release your proprietary or sensitive documents to any of your customers or your users itself who don't have right level of classification. And finally, we also want to make sure that we keep updating our storage systems with the relevant information. If, for example, if you actually have the next batch of manufacturing output, let's say next batch of chips that got come through the manufacturing line, you want to process them in near real time to do the analysis. You don't want to predict on the previous manufacturing batch, which is might not be relevant to the current batch. So you want to catch up and make sure that your search reflects on the latest and relevant information that is going to help answer your questions. And finally, you also make sure the challenge you have is the scalability part of it, where you need to scale to tens or hundreds of thousands of pipelines or machines that you have. At the manufacturing scale you have, you want to make sure that you can scale your processing and data extraction and answering things at the scale of your factories. And you should not be limited by software or hardware limitations that are in the current RAG solutions, right? So our solution basically, as I mentioned earlier, is the content-aware infrastructure, where we are fundamentally changing the paradigm of how storage operates. Today, storage is a dumb entity where people deal with bits and bytes of information. We want to flip the equation saying that, hey, can we actually push in data and AI database and AI technology in order to build intelligent storage systems, where the systems will automatically understand not only that there is data present in it, it understands the type of data and has the ability to process the data to extract out the knowledge or the informations from it to help answer your questions or help agents, assist your agents to better complete your task for your particular domain or particular organization. Right? So we want to change the way that rather than saying that I want to bring data from storage systems all the way to where the compute is, we are pushing the compute being next to the data, where we are bringing AI to the data to understand and extract out the knowledge so that we simplify and make your life straightforward. It becomes turnkey, where you bring in your data and automatically you should be able to start answering questions on your data without having to create processes, build new data scientists or AI teams to help do all of those activities for you. Right? So we announced the content-aware storage earlier this year at GTC 2025, where our goal is to significantly improve the inferencing processes, and we want to simplify the way organizers can extract information and perform document understanding on PDF presentations, audio, And we are starting to work on videos and other new data modalities and data types. We're also applying natural language processing to extract the information inside them so that we can better answer your search queries for you. Right? So from the key value that we want to give you, right? Again, the takeaway from for as you as customers is that we want to reduce the time to insight from months to hours or days. We want to create faster time to insight so that you can actually go from problem to solution without having to churn and iterate through this like with a huge team. And we want to create as simplified turnkey solution as possible so that you can reduce your cost, where you want to provide an appliance like capability that you roll in an appliance, it has everything that is built in to process your document, to serve your documents, and run agentic AI workloads, all of this in one single simple solution, right? And we want to simplify the operation by providing really good performance for you and lower TCO for you, right? So again, there are multiple use cases for our content-aware storage beyond just the AI assistants and agents. We can do real-time data synchronization between your different data sources that you have. We can streamline your AI data processing pipelines and provide enhanced searches for you, right? So what does it really take to do this content-aware storage? So fundamentally, there are four building pieces that you need to enable intelligence in storage solutions. The first one, of course, is an AI optimized storage. You need a storage solution. That's a no-brainer. The second part is the AI. What do we mean by AI is we need the ability to run AI pipelines or the data processing pipelines, such as NVIDIA technology, which is NIM. We also have IBM Red Hat technology, which is called RHEL AI. And we also support Watson X or another software solution from IBM with Watson X that we can run those pipelines to. The third component is the ability to search, right? Search is not a random brute force search. It's today, if you're trying to search on storage solutions, you can say that, hey, find my document that contain the word silicon, or let's say 2 nanometer or 5 nanometer. It tries to brute force search on your documents and see which keywords match. That's not going to help you to find more complex searches on your solution. What you want is you want to say that, hey, I have this image of a silicon. Maybe it's a good silicon or a bad silicon yield. And I want to say that I want to find other images of my yield that I've seen in the last 24 hours that are similar to this particular image. Can the storage system understand what that means? It should understand that it's the last 24 hours. Can it find similar images and give it to you? Same thing for documents, same thing for video and stuff. We want to provide complex searches through natural language, to semantic searches, to lexical searches, or even a combination of all of them, right? And finally, in order to run these pipelines or accelerate some of these indexing or the searches in databases, you need some hardware accelerators such as GPUs. So storage combines all of those things, and that is what we call as content-aware storage. Right? So what we provide as part of IBM is we provide support to run it on the cloud, or also for on-prem instances. Like if you want to put this in your factories, but have like compliance or data regulation requirements that you cannot ship your data to the cloud, you want to keep it within your AI in your manufacturing factories, even for performance or cost or compliance reasons, we can support both of these deployments. And IBM is a hybrid cloud company, so we can actually support deployments that span both on-prem and cloud, and it can work seamlessly across both environments too. And the best part about this is it's not a one-time process. Our solution will automatically detect changes or new data that's been added, and will automatically trigger the processing of these pipelines and update the solution so that your search that we provide as part of CAS will always reflect your latest data. And we partner with NVIDIA to provide acceleration, both from a storage to compute and between acceleration on data processing technologies from NVIDIA and others too. Okay. This is a high-level architecture of what we provide as part of CAS. Here, we actually built on a technology called IBM Fusion, and Fusion is both available as a software as a service on public clouds, not just IBM Cloud, but on other clouds such as AWS, Azure, and GCP. And we also provide, it's built on Red Hat OpenShift capabilities, and IBM, we have multiple different storage solutions. But for CAS, we actually use IBM Storage Scale, and we're also working on introducing IBM Ceph as part of a storage backend. And we can work with other storage solutions, not just IBM, but other open source solutions and other object storage solutions, both on-prem and on cloud. And we'll connect to these different AI inference services from IBM or for other third-party solutions that you have. Right? So this is an example of how we actually process multimodal data to extract PDFs. So it's a three-step process with NVIDIA's technology called NIM, excuse me, or NVIDIA Inference Microservices, which can extract the document, convert into text fragments, and vectorize them for search. And we provide a search API on top that can be used by Gen AI agents or Gen AI users, or even for chatbots if you have those particular applications, right? We do integrate this as a part of a larger ecosystem as NVIDIA AI Data Platform, where we provide the intelligent data information to your high-level agentic AI blueprints. Like earlier, there was a question about digital twins or other manufacturing blueprints. NVIDIA provides many of them as part of their agentic blueprints. We connect to them and we also run those agentic blueprints as part of a Fusion Agentic AI appliance that is actually going to be GA'd in December of this year. And we will connect to it and we'll accelerate all of your data and also the infrastructure to run this large language models. One of the problems that you're going to encounter is what is called as KV cache, right? What is KV cache is, it's not just a model that is large for large language models. The intermediate state in order to generate the response is called a KV cache. And that is also growing in size. It can even be 8x the size of the model length itself. If the model is a billion parameter or 100 billion parameter, this KV cache is going to be 800 billion, 8 times, which is 800 billion parameter sizes. That's quickly going to bloat and run out of GPU memory. So we have solutions in storage that can manage and seamlessly tier your KV cache across storage and compute transparently to accelerate your AI inferencing, right? And we, of course, we also have open source based data processing like Red Hat and IBM technologies that we have. It can also run on lower footprint or lower compute capable NVIDIA GPUs like NVIDIA L40S. If you're cost conscious, we can also work on lower cost, lower performance with open source smaller models too. And finally, we can also support at the scale that you want from a single rack to things that can run on AI factories on tens or hundreds or thousands of nodes or systems, where we can actually scale our processing pipeline, the search capability in terms of processing tens of terabytes of data per day or more. And we can actually do like deal with like a trillion tokens per day. And then we can actually have high performance networking between storage and compute and manage all of this for you in a simplified way so that you can focus on the problem and we can actually focus on the infrastructure challenges and the AI challenges you have and make all your data to be searchable by your agents or by your users or chat applications. Right? I'll take a few more minutes and I'll give some time for questions. So it's not just that we enable it, right? We also want to make sure that we can give you a 10x gain by only incrementally processing things that change so that you can focus and generate, we can focus on only doing incremental processing to generate the next 10x efficiencies for you, which is also important because in RAG or in terms of your inference applications, the freshness is the most important stuff. As I mentioned earlier, you don't want to be dealing with data that is like uh, two yields or two batches before. You want to be dealing with the current batch and you want the information to be available as soon as possible. So we can actually accelerate and do all of those things transparently for you, right? Finally, just to summarize, right? So again, what we can help you is to help unlock your business value in unstructured data. So the content-aware storage solution we have is a storage, compute, and a network all packaged into an appliance or in an as-a-service model on the cloud. It helps with accelerating your inference, simplifying your operations, and reducing your TCO. And we can automatically connect with your AI factory deployments or agentic framework like Watson X Orchestrate or NVIDIA's AIQ blueprints. And we can actually connect to your different enterprise data estate without having to create multiple copies or having the need to replicate your data. And we can transparently enforce your security and access control without having any specific inputs or redesigning from your point of view. As long as you have designed it for your storage system, we will take it and dutifully replicate it or enforce it in your uh, agentic AI or chat applications by connecting with the same access control mechanisms that you have for your storage solutions. Right? I hope I gave you a very high level overview of what can agents do, how can multi-agent systems work, and what is IBM doing in the context of agentic AI frameworks like Watson X or partnering with NVIDIA with AIQ agentic frameworks. Then I talked about how are we making storage intelligent to help you on your journey from transforming data into insights and enabling you to start on your agentic AI or you're transforming your manufacturing journey with AI enabled manufacturing to significantly improve your yield, lowering your cost, but without having to have a huge infrastructure cost that you're going to incur, by where we simplify all of the processes through content aware storage to fusion agentic AI solutions. I'll stop here and we can use the next 6 minutes for answering questions or have a discussion on things that you have on your mind.
Thank you, Swami. There was one question that came in during the second part of your discussion here regarding PDF document extraction as to why don't you use the IBM open source Python package dockling, I guess, because you were talking about PDF extraction a little bit earlier.
So that's a great question. So we do use dockling internally. For the Red Hat pipeline that I was showing before, we actually use dockling. So there are trade-offs in two parts, right? So dockling is getting popularity and it's actually getting bigger and better, but it does have limited support for different modalities, but they're adding support for speech, video, and other things, and it's getting bigger and better. So we don't want to restrict just with one type of solution, right? We want to provide you the broad capabilities so that you don't have to worry about what technology do I bring for different types of data processing. For PDF, we actually provide both NVIDIA's thing is called NV Ingest, and we also enable Dockling or Red Hat based document processing both. So if you want to provide you a rich capability to address your problem, if one is not good, we can try the other one and see how we can improve without you having to go through the process yourself to try with different solutions.
Okay.
Hope that answers your question.
Yeah, so I will open the floor. If there's other questions, please type them into the chat window. Yes, you got a smiley face from Daniel. So if there's other questions, I'd say please use the raised hand function or type them into the chat window and we'll give you the floor. I also do want to remind folks that we will send out the presentation and the recording most likely sometime next week to everybody that registered so that you can review this again. But I will ask for any additional comments or questions. And obviously, Swami, if there's something you would like to go back and highlight, please do so.
Yeah. So maybe I can ask a question to see what are your high-level challenges that you are facing in smart manufacturing today that you believe AI can solve, but it's not being, but you don't have enough technical understanding or the team to do that investigation for you.
Okay. Amba, your hand is raised.
Yeah, the point is, I mean, I come from a system design background and system design perspective. Actually, AI sort of a thing was already available long ago, like as in simulation. The first thing what we now call as AI was simulation. Even, for example, Cadence has got auto assisted, auto interactive. They call as auto interactive length matching, and sort of face tuning and all. I mean, though they call as AI, it is not AI, it is auto interactive. Human intervention. Use compute to certain extent, don't give it a full control, but you do it. So in the PCB layout and perspective, even for example, routing is very easy. Simulation 100% now, more or less. Compute. Routing is partially compute. But the main critical part of placement of devices and placement of silicon, still people, it's not taken off. I mean, it should have, but it's not taken off because of various issues, mostly IP related and stuff like that. So otherwise, I think this is where, people are going many iterative and things like that. The main reason is IP related and some sort of a data sovereignty sort of a thing. I think it will take off. But yeah, now we have been using all this. The main challenge was when the CAD came into picture in the 80s, people told that all persons who did schematic and simulation interactive will lose their jobs. It didn't happen. It became an industry by itself. Yeah, this is the right point. We are at the right stage. We have seen everything. We have seen interactive, auto interactive. Now we are seeing assisted, partially assisted, and AI assisted. Nice, but the assembly people, especially the component assembly and sort of even defect analysis, AI has taken in a big way because of sort of certain things are repetitive and things like that. Yeah, that's it. But it should have been other way around. I still feel that had we started from, say, some the design perspective, things would have been much sharper and much accelerated.
That's thanks, Amba. I think this is very insightful and helps us, right? So what I was hoping to trigger is to see if people are feeling the pain and want to explore adding AI more into this process to either with increasing yield or reducing defects. Again, it's all the same thing. Can we explore or do some POCs or joint exploration to see if that is something that we can do? And typically, someone has to be the trailblazer here. Once we drive and do some of those and we show it, others will definitely follow and try to incorporate more and more of these new technologies into the smart manufacturing process. We just need few trailblazers to pave the way for others to join in the revolution.
Thank you. Thank you, Amba. Thank you, Swami. Peter, you have your hand up.
Yes, hi. Thank you. Thank you very much for the presentation. I have a question, and maybe I'll call out another commercial product, but it's interesting to me. So I very much appreciated your RAG explanation and your context awareness on the RAG. At the Semicon show that just ended, I happened to meet with a company called Contextual AI, and of course they are also touting context-aware RAG systems quite. So I'm not affiliated, right? I'm just asking. But do you have benchmark comparisons by any chance? Because this is a the big discussion, everybody's saying, oh, just throw into Copilot or do this or that. Obviously, the value add of a RAG on steroids got to be our system, your system, got to be a lot more context aware than somebody else's. What can you tell us about that, please?
Absolutely. Okay. So first I want to clarify a couple of things and then I'll talk about the benchmark. There is two things. One is content aware, another one is context aware. So there's a subtle difference
Okay.
between the two. Content awareness, as I mentioned, is about understanding the document, right? The context awareness is basically the KV cache thing where you understand the context, like who is doing that work, and can you bring the history or the context into the picture so that you can better answer the question. For example, for what Agentic AI is good at is to say that, hey, you as you, let's say Peter, has been interacting with me, and it's not just Peter, Michael, Mark, Amba, all of them have been interacting with me. But I don't want to just intermix all your context to answer the next question from Peter. I need to know what did Peter do so that I have the history of Peter's chat or interactions and use it in order to bring relevant answers to you so that it over time it becomes more tuned to what Peter likes or Peter wants. Right? That is what we meant by context awareness. So one of the things that we are trying to do is, so we don't want to bring one for storage, one for content awareness, one for context awareness, and eventually there's going to be multiple other features that we want to add, like things that works in on-prem and cloud, like hybrid cloud. We want to provide you a single solution that can address all your problems without you have to buy 10 different solutions to solve this holistically, right? So that's one part of it most vendors don't do, right? The second thing is IBM is unique compared to other vendors because we have a full stack capability all the way from building agents and building platforms for agents to building hardware or providing storage solutions and even creating silicons or chips. So we can go all the way from the topmost user interaction, the APIs to the silicon level thing that we can do to optimize the value for you. And we can give you 10x or 100x better performance or lower TCO compared to others too. Right? So the third thing that I want to also talk about is the benchmarks that we have. So we are creating benchmarks. We're also establishing benchmarks, but today it's a wild, wild west. Everybody claims they are better than everybody else. So if you have a talk to some other vendor, they are going to say this thing too, right?
Yeah.
So it's a nightmare. We're having the same problem. Everybody says that they are better. So we are actually working on creating standards and community and how do we benchmark these things? What is the right way to do it? So we are part of the ML Common, ML Bench for RAG, KV cache and stuff. And we are also doing open source tools to say that, hey, this is what we get as our performance or accuracy, because eventually RAG is not just performance, it's performance, accuracy, and scalability. And people have to optimize all three things together. You cannot just do one at a time and magically say the other two are going to come together. It doesn't work. So we are establishing new metrics, new benchmarks so that everybody looks at it in the right way and solve this and move the industry towards the right direction.
Yeah, no. How could we stay in contact with you so maybe kindly restate again what consortium are you a part of? And it was something like AI benchmark or something like
Yeah,
this, or
ML
ML benchmark.
Commons, ML Bench. So how do you actually benchmark machine learning or AI workloads, right? So we are creating some of those.
Yep.
We're also creating open source tools. Once we have open sourced it, I'll share with the broader audience through Mark, and Mark can disseminate the information to all of you.
Yes.
On the benchmarks that we will have put in, and we'll publish results too, and we will openly challenge others in the industry to run the same thing. And because today we have this leaderboard for models, we have the same problem with AI models too. Everybody said, hey, GPT-4 is better than Claude, it's better than Gemini and stuff. And now they have these leaderboards where they're saying that, hey, run this workload out and then publish the results, and then we know who's better. So we are also going to create these benchmarks and results, and we publish those standards so that you have a good understanding of how to compare this in an apples to apples way.
Would there be a way, I mean, maybe I'm asking too much, that you paste your email so we can contact you directly about this progress? Because we're very interested in this benchmarking.
Yeah. So the easy part is my email is swami@ibm.com. I'll actually do that in the
Oh, that's easy.
PDF that I took.
But yeah, you
So
can just
luckily,
paste it
people
here.
said I actually paid someone to get me this ID. I did. So let me quickly flash it so that it's part of the
Yep.
recording and people have that.
No, thank you, Swami. Thank you so much.
So yeah, it's swami@ibm.com. So send an email. I'm
It's
happy to be
amazing.
in touch with you and then talk to you about it.
Yep.
Right? Again, I want to thank Mark, Shekhar, and others for the opportunity to talk about some of the things we've been doing, and thank you all for attending and keeping it interactive. Hopefully, you found this useful. And if there are parts of it that you would like to learn more about it, please let Mark or Shekhar know, and I can definitely have a follow-up series on any of the topics that you are interested in.
Yes, thank you, Swami. That would be great. If there are other questions or other deep dives that you'd like us to focus on, we can definitely do that. Just let me know, and we'll work to get Swami or others involved to provide some more education. If there's nothing else, we are a few minutes past time. I do appreciate your attention.
Yeah, unfortunately, I need to drop off to my